Number 50. Write the formula for the ionic compound formed from each cation and anion. Now looking at these, I can tell that the ones on the left are the cations. Even that one at the end. The reason I can tell that is because these are metals, and cations are normally metals. Okay. The only exception is this ammonium. Okay, and your chapter 3 discusses that one exception, which is called ammonium. So that's also a cation. It may not be a metal, but it is a cation. So the cations are on the left, the anions are on the right here. So there they are. Now, of course, the cations are going to be the positive ions and the anions are the negative ions. The way we write the formula is we figure out exactly what these cations are, what the formulas for the cations are, and what the formulas for the anions are. Then we can write the formula for the compound. So the metal cations are going to be pretty simple to figure out. We can go back to figure 3 points, not this one, 3.2. Okay, all of those metal cations are listed over here. Okay, so potassium is always a +1 cation. So here, for the first one, the formula for potassium ion is going to be K+, because anytime you have a potassium ion, it's K+. Okay, it's in the +1 column. Now magnesium is in the +2 column. Anytime you have a magnesium ion, it's going to be +2. So let's just write the formulas for all of these ions down. Lithium is in the +1 column. It's Li +1. And then potassium again is going to be K+. And then, now what about this last one? Ammonium. It's discussed in the textbook. The formula for ammonium it's got a positive charge, but the formula is actually NH4+. It's a polyatomic cation. It's the only time you'll see a cation that's not a metal. Okay, so remember its name. It's called ammonium, not ammonia. It's called ammonium. Okay, and that's ammonium. Okay, the rest of the cations are going to be metals. Now what about these anions here? Okay, I see lots of their names end in 8. 8, except for cyanide, but look at all this, 8, 8, 8, 8. Okay, that's kind of cluing me in. Whenever you see 8s and ites, you should be thinking polyatomic anion. Okay, whenever you see 8s and ites, look for the table of polyatomic anions. That's table it's at 3.3, 3.5. Okay, you see all these guys ends in 8s and ites. So what is bicarbonate? Okay, it's a polyatomic anion of carbon. Here it is, HCO3-. That's called hydrogen carbonate or bicarbonate. HCO3-. So let's go back. That's going to be HCO3-. Okay, and then let's do all of them. Nitrate. That's one of nitrogen. That's going to be NO3-. NO3-. And then what's the next one? Carbonate. That's CO3-2. CO3-2. And then we have cyanide. Now that doesn't end in 8 or ite. It's kind of an exception. You get a couple of those. Cyanide and hydroxide are polyatomic anions that don't end in 8 or ite, but they're still polyatomic anions. So you should, they're pretty common. So you'll learn the names eventually if you use the formulas enough. So cyanide is CN with a -1 charge. And then the last one is phosphate. Phosphate, that's one for phosphorus. That's PO4-3. PO4 minus 3. Okay, so that's at least the formulas of the ions separate from one another. Now let's write the formula for the compound. So the mistake would be to just write Mg plus 2 NO3 minus. Okay, there's several things wrong with this. First of all, an ionic compound, the charges are balanced, and so there is no overall charge. Okay, the positive balances the negative. Okay, so there is no overall charge. All right. And second of all, so you're not going to see charges in the formula for a compound. And second of all, this guy doesn't even balance that. Okay, the plus 2 doesn't balance the minus 1. The way you balance these guys is you're going to need 2 nitrates to balance the magnesium. So it may not. So this would be balanced. Okay, right there. Now that's not the way you write the formula. Is you basically write it like this: Mg, and then you have 2 nitrates. So parenthesize that, NO3 in parentheses 2. So that actually balances it. So let's get rid of all that other junk. Okay, and then take this. And then move it up there. So that's the formula. Okay. Now another way to know that you need 2 nitrates and 1 magnesium is you could do this. So you bring the 2 down there. You're going to need 2 nitrates, and then you're going to need 1 magnesium, and you see that will balance it. You got 1 of these. You don't have to write the 1. Okay, 2 of those. And so similarly here, and then there. So you're going to need 2 lithiums, because they're each plus 1. So you need 2 of those guys to balance the minus 2. So you need 2 lithiums and 1 carbonate. You don't have to parenthesize it if it's only 1. I made a mistake. So 1 carbonate. There you go. And then these already balance. So just, write them together, getting rid of the charge. These guys don't balance yet. You need oh, I forgot to do A, so we'll go back and do that. So these guys down here, you need 3 of the ammoniums and then 1 of the phosphates. So 3 ammoniums, you parenthesize that, and since it's a group of atoms, you need 3 of those, and then 1 phosphate. You don't have to parenthesize that. So that's the formula. Let's go back and do the first one. Looks like they already balance, and so just write them together. KHCO3.